It's really an LLM world right now, right? Like it or not, this is the world we're living in. Large language models control the world. And I don't know about you, but every time I'm walking into either my LinkedIn feed, Twitter, or I don't know, whatever Elon decides to call it now, or even threads, if this is what you like, this is how my feed looks like, right? Something between the lungs of a screenshot of I asked ChatGPT and answered a question and this is what it said, or look at this amazing demo I just built with large language models. And you know, ChatGPT, that pretty much everybody knows right now, actually started as a demo, which turned out to be a very, very successful product. But how many of these products are actually does demos actually become product? Well, as you can see here, not a lot, right? You can see that on the way from the left, everything, all the amount of demos that's starting, and on the road to production, somewhere along the way, we keep losing and losing and losing, and just a tiny sliver bit survived there. Really, all the great products start as good demos, but they don't really survive the way to production. And why am I saying that? Okay, so my name is Yuval. I'll introduce myself. I work at AI21 Labs, where we are one of the few LLM providers in the entire world. And also, we have a generative AI product, WordTune. You may have heard of it. Started as a writing assistant. Now it's a writing and reading assistant. Really a solution for everything you need. But on top of that, we also have a developer platform where we allow developers and LLP practitioners from all around the world to use our language models, such as the one powering ChatGPT, and also other dedicated APIs in the NLP realm. And this is what we offer in terms of foundation models, our Jurassic series. We have three different sizes: ultra, mid, and light. Each of them come with quality and affordability trade-off of its own. And really, why we call them Jurassic and why is this whole thing in a T-Rex taming? It's because that language models are like dinosaurs, really amazing. They're powerful, they're giant, and they're capable of many, many things. But it's really about the way we want to tame them. We need to handle them quite delicately in order to really understand what we're doing and how to get the best out of them. And here, in this case, how to get them from a demo to an actual product. Okay? And as a developer advocate, really, my role is to be in contact with a lot of the users, a lot of the people who use us and competitors, social medias, and so on. And I really seen a lot of common mistakes, either done by people in our company or by outside users. And really what I did is I distilled some of the best practices to work from there and really sharing from our experience, how can you start from a demo and finish with a product at the end. And for that, what we will do throughout this lecture is that we will build a product, an example, in this case, a financial assistant. So let's build one, okay? And every product starts with a good demo. So, okay, let's imagine that we now have a financial assistant and we want to ask it investment tips. So we're asking it, okay, what are the top 5 stocks I should invest in? Put this, okay, making it a prompt, put it into your language model, and we're getting something like this. Great, invest in those things. Are we happy? Do we have a demo? And like, really, no, right? This is boring. Something that a simple question for ChatGPT can do. Really, any screenshot in the last 9 months looks something like that. So let's do something a little bit more smart. Let's add another API integration. Let's take our question, run it in a Google search, retrieve some relevant data, and then feed this back, the data and the question, as a prompt to our language model. We now get another answer, more relevant answer, based on the data, the top performing stocks in S&P 500 2022. Here are my recommendations. This is much smarter, okay? Not a fully developed product, yes, but a demo, nonetheless. So it's time to celebrate, it's time to post it, right? So let's ask our favorite LLM, either ChatGPT or whatever else you like, to write something about us. We don't even have to write a tweet ourselves. And here we have it. Okay, here's a tweet. Unveil the financial assistant demo. You can do it. Hashtags in the end, and so on, and so on. But is it production worthy? Will someone be willing to pay for it? Will someone be willing to use this every day? Clearly, right, the answer is no. And here what we present is the survival guide, how to really go from a demo to a product. And the first and maybe the most important thing, which is the beginning for every product, is you have to find what we like to call here a product algo fit, or really a product vision. Something that people want to use, something that people will actually be willing to put money on. Okay, so just something that Google can do or something that a simple call for ChatGPT can do, it's not enough. You have to have something that gives an extra value, something good. Okay, the fact that this technology is awesome and amazing and can do a lot of things doesn't really interesting the user if it doesn't give some sort of value. Next is to know your constraints. And here, usually I mean unit economics. What do I mean by that? Okay, we have our famous graph of quality over cost, where usually the larger the model, the better the quality of the model. Okay, in most of the tasks. However, the larger the model, the higher the cost, and the higher is the latency. So really, you have to understand here what you can do. And a lot of the organizations, right, they're very happy with large models. They're seeing it, they're loving it. But when it's time to go to production, they usually focus more on the smaller models. And when we do have a smaller model, what we need to do is to understand how can we get the most out of it. And when I say get the most out of it, usually it contains several things. I will focus today on prompting best practices, a little bit about fine-tuning, and the hottest thing right now, retrieval augmented generation, or RAG in short. I will briefly explain at the end a bit about evaluation. Really, this is like one of the stages that a lot of people forget, and you shouldn't. So for most of the talk, what we're going to talk about is those things, and let's get started again throughout our entire financial assistant. So, right, we know ChatGPT, we may know models like Instruct, okay, and really most of the models right now are really with Instruct capabilities, meaning you can just provide them instructions and they will follow. And what do you mean they will follow? If you just provide them instructions, it means that they will follow according to whatever they learned on, whatever they trained on. So those models have a lot of bias towards their training data. And really, when you think about that, right, the training data is just lots of texts. But not all of those texts were written by experts in all subjects. So for instance, if you will ask a language model a financial question, you may get an answer based on the text that was written by economics professors or professional investors, but you may get something like a TikTok investment professional, right? Something that, I don't know, just a beginner wrote, or something that someone who's really not in your character. So if you want to think about it in mathematical ways, you can think about all the data that the model works on as somewhat of like a multimodal distribution. Okay, something that may look like this. And if you will ask the model just the question, it may return something based on whatever. But if you will direct it to sample from the mode that you want, it will provide the best results for you. So for our example, let's consider like a two mode where we have a conservative investors and risk taker investors. And now what we want to do is to use in the prompt, a lot of the times it's also referred to as a system message. So you can see here, for instance, you are a risk taker investments, you swing for the fences and believe in go big or go home. Okay, all of this, the beginning of the prompt. And then we ask the same question as before, what are the top 5 stocks I should invest in? And when you feed this to the model, it samples from the go big or go home mode. And it starts as a risk taker investment. Your investor strategy may be well suited for stocks with higher growth potential but higher risks, and so on and so on. Okay, the 3 dots indicate that the completion is very long. I spare that from you. However, if I will put in my prompt, okay, no, you are a conservative investor. Okay, you believe in steady, reliability, and so on. You will see that the completion is quite different. Okay, with that, you should focus on look for stocks in well-established companies, solid track records, and so on. Again, spared you from the long completion. Okay, so what I'm saying here is that you really want to direct the model to sample from the mode that you want, and you really need to tell it what kind of answer you are looking for. Another thing is that in prompts, much like in real estate, a lot of the time it's about location, location, location. And what do I mean by that? Okay, language models are really sensitive to the prompt and they tend to put more emphasis on what's in the end of the prompt. So for instance, let's make it a bit more smart. Let's say that we have now our report on our hands and we enter the model prompt which include an instruction. You'll be presented with a report, answer the question solely based on the report. If the answer is not there, say, I don't know. Now you can see the report in the brackets. Okay, let's say it's a long report. And then I ask a question. We get an answer, Netflix and Airbnb, which may be good if this is the report. However, in this case, the report I actually entered was about green energy, sustainable from 2022. Not Netflix nor Airbnb is in this report, I can tell you that. Meaning that the model kind of forgot. It kind of, right? Because the report was so long and the instruction was in the beginning. And really, language models are pleasers. They want to give you the answer. So it kind of forgot that I'd asked it to tell me that it doesn't know. So how can we solve that? Quite easily, really. Just location, right? It's all about where we're at. All I have to do is just put what it's important to me at the end of the prompt. So in this case, all the words are still the same here, but I'm starting with the report, again, in the brackets, and then the instruction, same instruction from before, after the report, and then the question. And okay, I set the same report, and now the model says, I don't know, which is good, which is what we wanted. Okay, so remember, recency bias, models have that, we should use it. We should really understand that. So up until now, we just covered two tips for instructions. However, now that we understand that and we are using those, is it still, like, can we use that? Is it production worthy? Can we take this and build a product out of it? And really, there are several problems here. Okay, sometimes instructions are not enough. And one, I can name two main cases when it happens. The first one is when you want specific format or style. So for instance, if you're saying write in our brand voice, something that a lot of stores, for instance, are really interested in, right? I want something in the style of, okay, a lot of companies have like a style of their documents or the way they talk. Or for instance, if I will tell the model I want something in style of Shakespeare, it knows what Shakespeare is, right? Because it's probably trained on it. But if I will ask it, write it like me after 3 drinks, the model doesn't know how I write and doesn't know how I write after 3 drinks, which is not great, by the way. So this is a case where the model can just not perform well. Another thing is smaller models, right? We talked about it before. Why do we want a smaller model? Because we care about the unit economics and we really care about latency. Smaller models are cheaper, smaller models are faster. However, smaller models are not as good with instruction in the entire of a lot of tasks. So in this case, what we want to do is to really take advantage of a feature of language models, which is the fact that they will follow patterns. Okay? Language models have a tendency to latch on some pattern in the input and then just follow through. So what do I mean by that? What we will do here, instead of just a simple prompt, we will build what is called a few-shot prompt, okay? Where shot is an example, and essentially this is a prompt that includes few examples of input-output pairs, and then we want the model just leave the last input or query empty, and we want the model to follow through and complete it. So you can see here in this case we have a 2-shot prompt, okay, where the instruction is a good name for a modern tech boy band is, and then we provide examples. So we gave it an async and Backstreet DevOps, and then we left it off where again we have a separator between every example. And now what the model will do is it will follow through in the same spirit of what we did. So in case you don't know, if you're not a 90s brat like me, okay, those are very famous boy bands from the 90s, from the early 2000s, and just like with a spin of a twist of something of a tech company. Okay, so you can see system of a dev. Okay, so in bold you see the completion, and this is great, right? This is exactly what we wanted. The model understood the pattern and followed through. And when we do provide examples to the model, it's really, really, really important to remember that we have a distribution for what we want, or it's really easier to talk about dimension. And what we want to do is to cover all the output dimensions when we give example to the model. Okay, so let's consider our toy example here of the product, where we have our financial assistant, and our dimensions is, let's say, length and a persona. So a length means either short or long answer, and a persona means either like a financial expert or your average Joe, someone like me who doesn't understand finance almost at all. And let's see what happens. Okay, so let's say that in this particular prompt, we are giving the report. Again, in brackets, it's really a long report. And then we're saying, based on the report above, what is your recommendations? And make sure the answer is short and for a beginner. Okay, and in this case, what we're doing is working with a smaller model. Okay, so our model is now smaller than before. And you can see that even though we asked it to be short, it's quite long, right? I don't expect you to read it. It's long, it's tedious, it's not nice. So what we want to do is to provide the model examples so it will understand and it can have an easier time to follow our instructions. So you can see here, we're building a few shot prompt for this case. So it follows the same pattern and it has a separator between them. Okay, so we have the report, and then based on that, so the first example, we're doing long and beginner. You can see here, again, this is very, very long. I just, for the slide, had to cut it off. A separator. And now again, another example. So our report, and now it's short for an expert. Separator, and again, report and short for a beginner. But hopefully the model can generalize if it already sees something short and something for a beginner, it can generalize. And indeed, it does. It works. Okay, so really what you need to take from it is that when you have your output dimensions of the problem, what you want to do is to hit all of them. Okay, so think about a cube. What you want is to really take the diagonal from that, really showing the model some examples from whatever and wherever. Okay, instead of showing the entire thing. Whereas here, if I wanted to show all the examples, right, it would just be 4. But right, if we have more dimensions or more, like the size of every dimension is bigger, we will have a problem. So in some cases, we just don't have a choice. And really, the problem with what I just said before is that models, right, if we will give them all the examples, we're really showing them a lot of things. And like we said about the recency bias, where the model puts more emphasis on the end of the prompt, it's also true for the entire prompt at all, right? The model really puts more emphasis on the prompt than on the training data and whatever embedded inside of it. And if we will provide the model with, with like a lot of different examples in the prompt, we may get a situation of we covered too much in the prompt, and this will maybe not be the best results. So if you do have a lot of examples in your hand and you want to try something else, what you can do is to try and work with a similarity metric in order to build the perfect prompt every time. And what do I mean by that? Okay, so let's imagine that we have a lot of examples, a lot of shots in a bucket waiting for us. Okay, and we have a query. And what we want to do is to take the most relevant, most similar queries the most similar shots to the query. Okay, so imagine that every color here represents a different type of domain in investments, and now our query asks for something green energy. Okay, so what I want to do is because my prompt is very limited, okay, the context window is a thing. And even if it's not a thing, it's like a long context window, still a problem. I want to build the best few shot prompt that I can. So I will use some sort of similarity metric, usually, and the most popular thing is embedding currently. Okay, so I will check the similarity, the semantic similarity between my query and all of the few shot prompts. I will take the top, in this case, 2, but whatever works for you. I will build from that the best few shot prompt as possible, in the sense that this is the most relevant few shot prompt to this specific query. And this will be fed into the model. So essentially, what we have here is that every time for every query, our few shot prompt will be different, but it will be better. It will work better for this specific case. And so we covered those things. However, what happens if my questions are more complex? Okay, up until now, we only have very straightforward questions. But let's say that I have this type of question, right? I really like to play with mathematics a bit. And I'm asking, well, my portfolio had 23 stocks. And if I sell 20 during lunch and I bought 6 more at the evening, how many stocks do I have? And if I will ask you right now, on the top of your head, what's the answer? Is it 5? Is it 9? Is it 3? 7? 11? It's problematic, right? It's not an answer that you can just whip out. You have to either write something, or at least in your head, go through several steps. And right, this is where we need reasoning. We need multi-steps in the answering process. Okay, and let's say that if we just put it into a model, there are 5 stocks, which I can tell you is the wrong answer. So what can we do? Okay, introducing something which is called chain of thoughts. Okay, it's a word from last year, which essentially just says, well, if a human will break this type of complex question into several smaller problems and solve each of them and then combine everything, why not ask the model the same? So we have the same prompt from before, but now we're just adding, let's think step by step. Enter this to the model, and now the model thinks step by step. So it says, well, I started with 23. Now, after I sold 20, I have 23 minus 20, which is 3. Now I bought 6 more, so I have 3 plus 6, which is 9. So the final answer is 9. Great, we're happy, right? But the same thing that we talked about before still happens now, okay? A smaller model may not handle this the best way. Okay, so again, same prompt, smaller model. You can see here, and what you can see here specifically is a screenshot from our playground, which is a no-code environment where you can interact with our language models. And you can see Jurassic 2 Lite, which is our smallest model, and it says something along, 32 stocks. Not good. How can we solve it? Just the way we talked about before, right? We said that if we want to go smaller, few shot is probably the way to improve it. And here you can see, instead of just give it just an instruction, I gave an example. So I have a question and an answer in the same format. And now a question, same question from before, and the model followed through, got a great result. Okay, so it works with this as well. Few shot for smaller models is better than instructions on smaller models. But does it always work? Like, will it always give a good answer? So if you will actually try it, you will see that working with zero temperature and make it deterministic can cause a lot of errors, right? The distribution may be very, very close to one another, the tokens, and it may really be very, very certain at a mistake. But when you work with higher temperature, like usually we do it here, then your results may not be as stable. And really, this really reminds us of the concept of weak learners, right? Where essentially it's a concept where if we have a weak learner, something that is correct in rather, small percent of the times, if I can take a lot of them and then do a majority vote, what we will get is a better learner, right? So essentially we're like boosting them. And this is exactly what they did in the following paper, which is called self-consistency, or really just boosting chain of thoughts. Okay, in this case, what we're doing is we're taking the prompt, and instead of sampling one time, we're sampling several times. and taking the majority vote. Okay, so you can see here, out of 3 times, 2 times we got a correct answer, which is the winner. Okay, another thing that they use to explain that, which I really like, is a principle from logic, which essentially says that there is the right place, the place to start from, and the right place to go, and you can go in many ways to this right place, but you will always end up there. Okay, so if you will sample enough times, the majority will take. Now, this is very, very good for reasoning. This is very, very good for complex questions, but you have to remember, okay, all those calls are adding up, and this starting to cost. So again, this is for a larger model. For a smaller model, you probably want to do a few shots and sample from that, or even not go through the boosting. Maybe this is not the right approach for actually production, but more for generating data and so on. So just to recap all the prompting best practices that we talked about before we will move again. So we talked about instructions, where I want to inspire from the multimodal distribution. So I want to direct the model by some sort of a system message to sample from the right mode. We talked about the recency bias, put the important stuff at the end of the prompt. Then we move to few shot because smaller models, unit economic. Then, okay, so cover all the output distribution, or make the few shot prompt as relevant as possible if you have a lot of them. And we talked about chain of thoughts and self-consistency in reasoning here. But up until now, we just brought a report. And really, the more realistic scenario right now with organizations is data. Data. A lot of organizations have enormous amount of organizational data, organizational knowledge base, and they want to do something with it. And what is the biggest misconception that I always hear, the first thing that a client tells us is, I have a lot of data, I want to fine-tune a model. And here is where you have to ask yourself, do I really need fine-tuning? And I found an explanation which I figured that works a lot of the times and really helps to clarify. And the first question is, well, when you have a lot of data and you want that your model to be trained on, do you expect the model will write like something, like your style, like your tone of voice, like your brand, and so on? If the answer is yes, then great. And essentially, you can think about it as really like a generalization of few shot. Okay, so in fine-tuning, what happens is that we literally change the model's weights in order to fit your data. We're doing it more training, more epochs. Okay, either full fine-tuning, just several layers, or there are prompt tuning or LoRa, like more efficient methods today that you can use. But this is essentially what happens there. How do you do it? So again, taking advantage of your input-output examples that you have and really showing the model, making it much more biased toward working like this. And when do you do it? So when you have a smaller model where a few shot just doesn't work, you have a lot of dimensions, a lot of things to do. Okay, so this is really a good place to work. And also when you have a lot of data, okay, just writing data for that may not be always the optimal case. And you can see what happens is that when we do fine-tuning, we don't need the few shot anymore. So if you remember, this is the case where the small model failed. Again, we wanted something short, but it gave us something long. But now we trained a model. You can see it is our model now. And with the same prompt, boom, we get something good. Okay, so this is the concept of fine-tuning. This is when you need fine-tuning. However, and this is the more common case these days that I found, if what you want to say is, I want my model to write about something. I wanted to write a report based on my data. I wanted to collect insights based on my latest reports, and so on and so on. I don't want hallucinations. I don't want to make up stuff. This means that you probably want RAG. So in very short, what is the concept of RAG? Okay, so we have a user which asks a question or some sort of a query. It goes through some sort of an API, which directs the entire system. This then takes a query to a retrieval mechanism, which is essentially some sort of similarity metric, usually embedding, and a vector database. which search over this query what are the most relevant documents inside of the organizational data, then retrieves the top K documents. K can be 3, can be 100, whatever you prefer. This all goes back to the API, where it builds a prompt based on the question and the documents, goes through a language model, in this case, AI21 Jurassic 2 Ultra, my favorite. This LLM returns some sort of a completion, and this will give the answer to the user. And really, today, you can do it with language models. You don't have to. You can have like a task-specific API or something which is really dedicated. For instance, what we offer in this thing is the contextual answer model, which you don't need to prompt. You don't need to all the prompt engineering. You can just replace it here, and then the question just go into the model, and you just get the answer without prompts, and it's much more specific for this case. And you can see here we have the full solution where we actually give you the database and so on. You can see here an example of our organizational database where now we ask how many days can a person work from home, where if you will ask any language model that, it will not know how to answer, right? Because it's based per company. But here you can see working from home 2 days, and you get some sort of attribution. You know where it came from. So let's just recap on our survival guide and then talk a little 1 minute about the evaluation. So Ken, I cannot stress this enough. Have a clear product vision. Okay? Product algo fit is the way to go. Again, those models really like dinosaurs, really, really powerful, a bit unpredictable, and you really need to tame it. You really need to understand how to get the best out of them. Know your constraints, the unit economics, okay? If you will not earn money, you will not have a product. And we covered the prompting best practices, whether it's instructions, few shots, and complex questions, fine-tuning and RAG and the differences. And I just want to take like a few more seconds and talk about evaluation, because this is something that a lot of people underestimate or forget. And in my experience, really a lot of the companies just forget to do it and like, oh, it will be fine. And usually what happens is that they're just eyeballing a small scale of examples. And okay, this is good, or okay, this is not good. And if you're talking about a production that is at scale, just look at 10 examples. You may overfit your prompt. You may have some problems. Okay, it's not something that you can count on. And really, automatic metrics such as Rouge, Blue, whatever, work really well in academia, and not as much in the real world. And so what you really want to do in the real world, maybe build something which contains several of them or something like that. We do have works now about large language models as a judge, essentially meaning that those models say if a completion is good or not. Still very problematic. Those are very biased towards themselves. They are heavy, really prefer repetitions and like long completions, which is not always ideal. Really, still no good replacement for human expert, content evaluator. And I cannot stress this enough. Reliability is the key. You can do everything right, but if your model slips something, if you're not putting the correct guardrails at the end, if you're not evaluating what your performance correctly, it's still a problem. Okay, so really, you have now most of the information to really take your demo and build a great product throughout of it. And hey, I'm here. Come talk to us if you want. We will very, very, very happy to help. And thank you very much.